Hello. I eyeballed the size of the rect over there, but it seems good actually. Let me see. Yeah, might be a bit too high. Okay. That should be good enough. Okay. We can continue. I think all looks good. Should I do one less with this one? Yeah, I think that's better. Okay. With that, let's see, where were we last time? I think I did like 1 or 2 minutes more after I stopped. So we were building this graph, and I did add this annotation that I possibly will not keep the amount or percentage part here and just do number, because it just makes it more complicated, and in the end I basically require everything to be number anyway, or like of the same type, so it must be all amount, or it must be all percentage. So if I do that anyway, there's no need to have the switch here because I treat everything the same, but I think we'll just keep it and like pull it through the stack and then in the end see what we can reduce just to get more progress quicker. Okay, so then, yeah, this one is awful with the naming of stuff and sample, and then this and here you basically do X, Y stuff, and then it's really not the difficulty that you expect is like nowhere in here name-wise, so yeah. That's not the best, but what I added was this for loop. So let us check this, if that's correct, and then we see if we can just plot it. And when we fix that, you will also see the current state in the top right and no longer that weird error. Okay, so we get values. We need to check with our sections that we have. I should directly open GIMP again. And like every single time I should have set up the tablet, which would be way better. Actually, I think I'll do that now. Because it's so much better and so much cooler. Let me check. Okay. Where do I put it though? Because I have T standing here for when the T is ready. So there's not so much space. Okay, now there's space. I don't recall though how I did that, so I need to check that. Remote above, remote full. I mean, any remote would be great. Remote play white color. I guess I would just copy remote play, place it in here, and then let's see the settings. Any Steam client that has Sketchbook on it, automatic. Okay. That looks okay, or right. Um, okay, that's working. Great. Oh, okay. And then, of course, it has the weird bug that it sometimes has. Why shouldn't it? It's like a Surface, which they have this weird thing that in the top right corner, it's sometimes just broken for no reason. And I don't really know when and how to fix that. Let's open Steam. Okay, Steam is not opening. Oh, it just takes forever. I see. I think I prepped something there that I can just... oh, that's interesting. I think I don't need that anymore, though. Oh no, I need to connect with Steam. Okay, this is taking longer than I expected. Okay. Getting there, getting there. I think. Except the damn arrow is still there. So annoying. I thought last time that I found out how to fix that by just like locking, unlocking the display ones. But it seems like that's not enough. Okay, let's see. Also, this will of course drag my internet connection way more. Oh my god, I'm directly getting annoyed just because of that bug. Because I couldn't use it anyway if that continues. Why? Oh yeah, WordPad. So I do something like play WordPad here. And then here, let me hide for a second. Let's at least see if it will work. I open Steam, and I think then I just do remote play. Except of the bug. So, games, WordPad, stream. Okay. And then I should be able to go here. And this is actually already there. Oh yeah, there it is. Okay. So I could just switch between those then by doing this. And then the problem is that I won't get rid of that thing in the corner at all. Okay, but I, in theory, would have that here now and could just draw, right? Okay, but I should do it bigger. And I did I cut everything? Yeah, I think that's fine. I just need to be way bigger. That's kind of visible, but could be even bigger. Okay, so basically, I wanted to stop saying basically. What we have here now is we have this graph and have like, oh, what was the back control? Doesn't matter. Why did it not pick the color for me? Oh, because we're in the black range. Okay. And we have like a graph. And then we section this into whatever we want. But the rule would be everything that has the same type. So this, for example, would be polynomial till maybe here. Is one section. So if we have this section here, that's what we do with a graph. So let's actually also get rid of this graph again and do it like section wise. So we could have that, skip that, and then have this. And then what we would do is pick these points. And then maybe also there's a point here, there's a point here, and then maybe something there, doesn't matter. And then our sections would be all of the same type. So these are sections in themselves. Oh, I need to turn the record player. In fact, I did not turn the record player, but just the record, but I think that was clear. And then these sections is what we have in here. And these sections then can contain multiple points, but they will always have like a beginning and an end. So this will like be, that's still too thick. Maybe I should just put that here. This will always be start and start and start and. Let me actually hide a second and quit Discord. How? Yeah, I think it's closed. Okay, so this is what we always have, like start, end, start, end, start, end. But then this one additionally has like between points. So this has a B1 and a B2. And what I will do is take the points and interpolate. So the type of the type of this part here is linear, and then the type of this here is constant, or I think here it's called step function, and then the type of this entire thing will be polynomial. And that's basically how I want to have this working, and I think we are there now. So if we have like the code now, with the sampling, and we have have like x values, which here like this is x, right? And it represents the difficulty, and then this is y, which represents the chance of things. Good song. So these x values are our difficulty in our difficulty graph, and we want to know what the chances of each of the difficulties. And for that, we first need to find the correct section to then use the interpolation on that section, which here means that we have to iterate through all these values and first find out which section applies. And I don't know if this actually works, but that was what I like quickly did as the battery. The battery is fine. Okay. Which I quickly did last time when finishing. So I'm not sure if this is correct, but what I thought was I just filter that and then take the last element. So I remove everything that's x value wise. This dot value is always there because we have these amount of percentage things, which is already annoying here. So I want to get rid of that, hopefully at some point. Let me check though if there's maybe some obvious you know, ChatGPT alternative to do this, which is like the way you do it in TypeScript or JavaScript. Because in like C++ or something, I would just do a find and take the first object that applies the criteria, but I have no idea how or if there's like find stuff similar to this. There is. Okay, let's just do that. No need to ask any artificial intelligence. I will need to finish my tea, or finish the tea prep though. Will only take a moment. Okay. Now it needs a better place. Maybe I just try and drink with my left hand. I'm not sure if that's a smart idea. Okay. So if there's a find method, we just do that. Way better. So we do find, and then what's going in there? Value is section. Okay. So I can just do a function and then check for the section, I think. So basically the same as here. And I said it again. God damn it. It is the same as there. It's not basically the same. Section. So we get any section in that section's list. We see if the section start value. Is that correct? Let me see. If we are... I need to make that bigger. And then I can use this to point maybe with an yellow value. No, yellow is awful to see. Let's take purple. Okay, yeah, you can see now. So I want to know where I am, right? And if I'm here, x-wise, like the y value does not matter, right? I want to get this section below me. So assuming that the sections are sorted anyway, which I think is a condition I have below, which just makes sense. The first element, which has start value that is smaller. No, the first section that has an end value that is bigger than my point is this section I want to look at, I think. So we have this endpoint here, and we want to compare these two. Okay, let's remove that because that clutters this thing if I want to draw more later. But I think that's what we need. So we have this section we're checking. We're checking the endpoint. So what I wrote here then even was false, I think. We check the endpoint, and that should be bigger. Oh, we should have a better example too. Like if we have x here, and we check the first section, endpoint is smaller. Then we check the second section, endpoint is bigger, works. We take that one. And then if we have x here, same thing. And if we are beyond that, that's like a special case that I need to do something about later. So let's note this. What to do when we should extrapolate? Just check bounds. Just check if nothing is found, and then actually it's only if we are after, because we always start at 0. Below that does not make any sense, I think. Maybe. I mean, it would make sense, but it makes it more complicated, so I want to start at 0 always. Just check if nothing is found, and then use last section with extrapolation. Okay, but we don't do that now. Section. Fitting section? I don't know. I like speaking names, so I need to write less comments, which I never do, so that's a good thing then. Somehow I'm, again, so far to the right in my camera and not in the center. That's bothering. Did I get angry some days ago or something and slammed my desk and the camera moved? How did that happen? Okay, let's see. So then we grab this. Oh yeah, we need to get the value, because else it will just compare the object's references, which would be annoying to find as an error. Then we check the element, the value that we currently have and that we want to get something for. I wonder if I somehow can like get the value here directly and not that just the key. But the first result was this style, so I think I just stick to it. Okay. So we have that, we have the key, we get the value of that thing. No, we get x and then the value of that thing. Because it's actually not even an... Is it an x value? It is, it is. No, it is. So the first time the end is... Damn, what did I say? Bigger or smaller? Bigger. Yeah, the first time the end is bigger. The end is bigger than our value. We pick that section. Found section. I don't know. So we don't do the filtering. We don't do this. And then with the found section, we can take the found section, which should be a section, hopefully, which it is not. Oh, it is section or undefined because it possibly is nothing. Right. Okay. Or undefined. If found section undefined, if there is no section found, as we start with 0 and guarantee. I hate English. Guarantee a section to exist. If there's no section found, as we start with 0 and guarantee sections from there on exist. Okay. Today my writing is on point. Exist. We can just pick the last section for extrapolation. Okay, which means that found sections can no longer be const but must be a let, and it will be sections of sections length -1, I think. And then we know that the found section is no longer undefined because we know that this section will be bigger than 0, I think. But check that. I don't throw if there are no sections in there. I should do that. So if that's 0, throw something. This is illegal. The graph needs at least one section. And then this all can go down, this can go away. This can be an else if. I'm not sure how. Does my auto format not work? I'm not sure. Okay, so this is not the style that I use normally, but I'm not sure how it actually is usually. If I do this now, okay, so that's how it wants that to be. Okay. Yeah, we throw just things, we do stuff. Now we can be sure for now that that's working and this is not illegal. We use this f with the value in x. And with f, we just get the interpolation. And extrapolation should also work. So this should now be correct. Which means we could make some example and plot it. Maybe we even try to recreate our example on the tablet. Okay. Then we do this spreading. Why do we do this spreading? Oh yeah, because we, in the end, we get like a list of x values. Oh, that's actually a problem. So the great thing about having this combined section is that the thing can be smoother. And that it will not be like, if you look at the parts below, it will not be something like this, then like this, and then it has like hard corners and is not smooth. But that means that I need to put it in there grouped together. So when I want to sample it, and I have just like these x values, and I sample them individually, I'm not sure if this will work. Oh no, because it's separate. No, it will work. It will work. Because my points are already in there. I forgot. Yeah, we have already set the sample points. So this is just the sampling itself, and that doesn't care. Which also means that this will always be just one value, but that's fine. And then as this will always be one value, we want to get it out of its array, which this will return as like an array. We get that one element out of there, put it to our return values, and then return all the samples. Okay. That's great. I think we listen to this record again, and then I switch to another one. Let me do that now. Okay. What we also need to do, or should do, is my left. Hello, test, 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 test. Somehow it sounds to me as if my voice is only on the right side and not stereo. That's weird. The question is it... Oh, now it's working again. Weird. Maybe the headphones are broken. I feel like they break so fast if they are on a microphone because it just splits itself in half. You can't see that, right? It splits itself in half because it's always twisted because I just pick it up and put it in. And these that I like are like $20, so I don't like that they break so easily. But maybe it's something else. Anyway, I think the inverse sampling I will do at some other point, because that's some math we need to do, and I want to see results first, and then we can maybe do that next. Oh, come on, I just want to place it again. Okay. Which means we now want to create a difficulty graph, which also would be annoying because I again have these stupid amount of percentage types in there. Okay. I give in a list of sections, right? I do. So what we do here now is difficulty graph. And that has a list of sections. These sections have a start of type sample point with x being amount of percentage. Oh, that's so annoying. I mean, later I map this stuff, right? But now I need to do this weird 50%, you know? So stupid. Anyway, difficulties. Let's just enumerate this. So this will be 1, 2, 0, 1, 2, 3, 4, 5. 5 difficulties. So we're actually doing that like this. Then we have y is amount of percentage. I hate that already. And this is of type 0%. Also, I need to correct and scale this afterwards anyway to fit to fit like the so basically if I randomly put these points in here, the sum of all this, right? You interpolate all of this. Oh, so we could never extrapolate actually, because this will be 1. It must end there. All this below the curve must be 1, all that together. Else we don't have the probability density function and guarantee that everything hits. So actually, if we pick something outside, that's just illegal. I can't extrapolate. That's not valid to pick there. So that should throw an exception. Which would be this case actually. Let's still keep it, but say throw for now. This is illegal. If we would extrapolate, this would not be a PDF. Don't try that. Okay. Something here is still not okay for it. Oh, because it only has that yet. We also need end. What else do you want here? Interpolator would in this case be step. No, it would be linear. Linear. What's now your problem? Why should I why should I override F? Is that the wrong way to define a function? Because I don't want to override F. F is like done, right? Property F is missing in type. TypeScript. Oh, you can't see that. I should add some shortcut to switch between them or move my my stats somewhere else so I can still see if the stream is still on while switching between them by mouse click. Okay, type script class with a and function. Giving the error property function is missing in type. Let's check in my class. Maybe something must be longer than f, but I don't believe that. My function. No, that looks fine. Yeah, actually it will not. Is it maybe not a class? It is. Wait, but it's not exported. How can I even use it? Don't I need to export that one so that I can use that? And then also get it? I think because I think I need to create it with a constructor. That's the problem here. And then with a constructor, I don't need to put this here, I guess. Oh. Okay. No longer complaining. That's great. Let's make this more compact if it allows us to. The auto. Yeah, okay. So I have a section now. Let me switch back. The second section, and then this is where I now struggled with, I have no idea if this is scaled to 1 or not in the end, which will be annoying. And I don't know yet how I make sure that that will be. Anyway, 15%. I'm currently questioning if it's even smart to do it like that, but I don't know. We have this way too complicated thing now. We will try to finish it like that. Am I just sometimes sitting different? I'm again not in the middle. Anyway, let's just go with 15%. I don't know. And then we do the next section. That makes no sense because the other sections will use these. Okay, so grabbing this. 2 more sections. They start at 1 and go to 2. This is step, where step basically picks the value of the left side, which here would be, maybe put 15 there, put 10 there. And then this value actually doesn't matter, but it would also be 15. And then for this one, we actually have like these 2 points extra. Which would be 0.3. Oh, we are at 2. We go to 3, we go to 4, we go to 5. And then we start again at 15%. Go to, I don't know, 20, 25, then down to 20, and then up again to 25. Let's say to 30. This does not sum up to 1. Definitely not. Let's just reduce everything a bit and then see how it looks. Still no chance this will be 1 in the end. And this should be polynomial. Okay, that should create our diff graph. Graph. Okay. With that, we should now be able to sample this. So if I have an X array, that samples us points. Oh yeah, this is so annoying. Because with how the where is it? The other thing works. I think it has also like line space, so I could generate as many points as I want. But then I would need to map them to amount or percentage all the time. That's so stupid. Oh yeah, let's hide this for now. Where is it? There. Okay. And then we go here and copy that link. Okay. Line space. Maybe that was the other example. Because I think this one is also able to sample between the points. At least for showing. Yeah. No customization needed yet. I mean, I can just do a for loop, right? But it's just so neat to have these line space things because you can just easily adjust the precision and all of that. It's time to return the record first. Okay. Yeah, maybe I'm confusing this with something else. Okay, let's turn it. And I should also drag it here if I'm searching there for longer. Wow. Okay. I don't have like the patience today, I think, for searching. So we'll just do things instead of finding them. Or find the nice way on how to do them. Geduld for loop. Let I be 0. And I mean it must be 5, right? Because this is our max value. Which I should later on I should find that one out. Max X is 5. Yeah, I do need to get rid of amount or percentage. That's so annoying. I need to do those checks before. Find this value from the sections or something like that. Sections, last section, something like that. Okay, and then we can go to max X. Oh yeah, because this is not amount or percentage. No, wait. No, that should be fine. What's your problem? That's your error you're telling me? No. Okay, let's just continue and see if something else comes up later. X. Well, this is X's. X's. Push. I. The string. Okay. Oh. Classic one. Okay. There seems to be two little clothings. I don't know. Okay, now we have our X's, and we will get our Y's with this. Amount of percentage, right? Sample axis. Oh yeah. So we have this now. I wonder why this is white. Can this be? Okay. Console. Huh? The above error code in app component at app. Consider adding error boundary. Uncount. Illegal. The first section must start with a 0 as X value. So I think you don't know what you're talking about. It does. Is now already the time to remove them? Oh yeah, oh yeah. Because here, of course, I'm missing value, which is so stupid. Which again also here is missing. Because I love JavaScript. Okay, there we go. I was so close on making these all just numbers. Okay, so we have these x's and y's now, and now we need to put them into a data, and that data will go in here. No, it will not. Where will it go? Chart, axis, victory bar. Well, we don't even want a bar, right? So let's check this again. We want a line. Okay. So we do a line. Data accessor for x values. Interesting. What does that mean? Where's my data? Oh, because it's... Yeah, okay. I don't have it in that format actually, right? So maybe I should return it in that format later on. Which is worth a note. So this should actually return sample points. So maybe rename them to points. And then return them. And not just the x values. Okay. Which actually will be no extra effort. Because I have them here already, I can just feed them in here. This dot thing might be annoying, but because I know that it will be only one value at a time, I could just get the first element, because that will guaranteed be there. I think. Guaranteed be there. Okay. We have that node, that's enough for now. So we definitely get rid of that. We have a difficulty graph, we have our points, we have sampled them. We have an x's and y's, and now we need to create the data. So I guess we now iterate again. Data will be number. How'd I do it like that? X number, Y number? Like this. Okay. Now we go through the keys in the axis or IDs or whatever, and then what will this be though? Will this be this is a string? I actually want the indexes, so I think this is just faster to do as well, especially because this is just temporary, right? Data dot push, because this is so annoying with the amount and percentage stuff that I will not keep it like that. Okay, so we put in for x is at I dot value, and then the same for y. And then something is wrong because it's not an object yet. Okay. Now data should contain the points as we want them. And then also this is interesting, but we don't need that. Domain padding material, whatever. We don't need these because it will be just... Oh wait, this is also still the bar. Don't need the bar. We want victory line. Okay. Let's see how this looks. Data, parent, something. Data. Okay. Huh. Damn it. I think it's not working. Okay, let's see. And print data. Console reload. Oh, there are problems. Why is none way too many times? Okay, that one is correct. This is a bit small. Can I make that bigger? Yeah, okay. And I could just bring it here. Then I can see it. So this one is correct. The rest is false, which is great. I think it's... In which direction is it outputted? Outputted? I think this is first, and then this gives the error. Attribute D, expected number. Oh, okay, because then it tries to print them. Received none for Y1. Oh yeah, okay. So the problem is before that this returns none. Which actually is happening in this sample method. Oh, we can still warn the data, it doesn't matter. This is so cursed and so bad from code perspective. But I rather want to make progress and then clean up later at the moment than rethink everything, because I have the general plan, and I think it's best to now with the general plan get to a working example, and then when I have that as a prototype, I see where I need to go and do what. That's the only reason I still stick with this, because at some point I thought it might be helpful, so we keep it for now. But yeah, I think that will be gone later on. Makes it so weird. Okay. Why is it none? I should be able to just... find it. Go away. And break here. I really need to know how I can debug directly from Visual Studio Code and not need to go in here, right? That would be great. So let's reload. Get this over here, get it bigger. Okay. This looks so weird to you because I changed the size. Right? Yeah. Oh, let's just... Oh no, it's still there because it's bigger. But I could do this. Okay. So let's see what is coming in here. I I haven't used this debugging in a while, so I don't know where my... Oh, there are local values. X. Cannot scroll in this, I think. No, then I scroll there, which is not what I want. 0 is 0, 1 is 1, X values, amount is true. That's okay. And then we F10, step over. F11, go in. Okay. And that works. Won't F11... Okay, it works. Great. So we go in here. We, I think, go over this. Because we just have the key 0. The X values. We go over this, and hopefully that's not broken yet. Found section. Has a start at 0, 0. Correct. No betweens, and ends with 0, 0.05. Also correct. We want to interpolate linearly. Okay. Interesting. This is the wrong thing. Because we are currently looking at the 1, I think I always want the next... do I want the most left or the most right? If I'm searching for 0 and put in 0, I want this one. And if I put in 0, oh no, the end will always already be afterwards. So the question now is, do I want this point or that point when I input exactly this value? I think it's best to think about this from the last point, because if that's in, then everything else will work. So I want to be able to get the last point. So if the last point is 5, my check needs to be if 5 is if my point is smaller than 5. But if my X value is actually exactly 5, I would still want to pick that one, right? So the first one I pick, which endpoint is after my X, but actually I should do after or equal, because else I couldn't pick the last point. So we will fix that real quick. So the end must be bigger or equal to the value. Okay, then that would work. But okay, so this is the correct section. So we have found the right section. The error must be in F then. Because this is now an entirely valid section. Okay, let's step into that, and then I'll okay, we are in here and I switch records. will be doom because I'm already so tired and I need engaging music. Engaging? Well, music that's loud and keeps me going. Okay. So what's happening here? Is this valid? Let's step over these two and see if they are right. They are right. 0, 1. They are not right. They are right. 0, 0, 1, 0, 0, 5. Okay. Then we get the interpolator. That's also correct. Now, what is the x value? And what is its value? Okay, that has amount value 0. So this should return 0. This should return 0. Which this should give, right? Values? What? How? These values are not... Oh, because this goddamn thing is not type safe. Because it's JavaScript. Can I do something like as number in here? Is that valid? Because that would make it safe. Or I could just wrap the methods, right? I could redo all of them, but I think it's... No, if I do as, then it will just convert it no matter what's in there, right? So I can do this. Oh no, it will complain. That's good. Yeah, that's great. Later, maybe we switch to number anyway, but we should have this check in place here for all of these damn things. And what I should do at some point is just add typing to these, and then I could even add that back to the repository. So let's note that too. Up here. And so much to do. At some point, I should add types for the repository so I don't have that weird ass number stuff. Okay. So the arrow here is that this is just wrong. Because this is not yet converted. Because I picked this instead of numbers. Is this a point to... Wait, are these also no? No, they are numbers. Because I put value here, yeah. Const real x. I just want to see if it works. We can fix all of that later. Please, just give me an output. Anything. And then this will be x map this. XXX. Value. Real X. Okay. No. Yes? No? No. Oh. Yeah. Yes. uh yes, no, yes, no, yes. Okay, this now. Man, one thing that's JavaScript and it's directly broken. Love that. So let's reload and just play it through. Graph. It's wrong, but we have a graph. Well, no, it's not wrong. I think it's not wrong. Oh, interesting. Let's remove this, make this to a feasible size again, bring it back here, and remove this, and then scroll. Can you don't get smaller by that? Mm, what am I doing? What is wrong with this thing? Oh, do you not have a width? Can I not use that for you? That's not valid. Oh, we should make it again. I see. I mean, okay, then we just diff around you. See no problem with that. And then you go in there. Okay. And now we just increase the sampling rate. So this will go from 0 to 5, but it will go by I equals I come on, just write const. It's not that hard. How's that classically called? Width? No. Let's just call it rate, doesn't matter. Sample rates, okay. This does not look better. Oh, yeah, because this is wrong. No, this okay. Yo, this is so stupid. Well, I mean, like, I'm so stupid with that. No, this is stupid. It's like working as it should, but source code. Why are we not even stopping there? Weird. Okay. App. Where's the Where's my code? Where code? Is that the wrong app? This looks better. Oh yeah, that's the wrong thing. Oh, how weird that it shows that here. Okay, good that I closed these. I should not show you them at all. Warning. Yeah, that's nice of you. Can I see that output, please? I mean, yeah, but I'm clearly really wrong with something here with this super basic for loop. So let's reload and see what's happening there. Sample rate is very low. Ice 0. 0 plus very low should be a bit more. Okay, let's do one iteration. One more. I mean, that's doing what it should. Where are we now? 0, 5. Still smaller than 5. Okay. So that's not the problem? Yeah, that's just a lot of points. Maybe a few too many points. But it should work. Let's see what one step further does. Okay, this also gives a lot of values. So that's okay. And then we push data. Oh, and data is there. I see. Of course. So it was a stupid me. Oh, I should close. I'll do it like that. Yeah, so the error is obvious. Second loop, it was not updated. Every property of undefined reading value. Where's that one? Hot update. Okay. Bundle.js. If I change this back, can you read again? What? Okay. This is completely equal. Now it's broken. Let's make sure it's not that no, this is the problem. Okay. See more errors. Reload. Reload. Console. Cannot read property of undefined reading value. Cannot read property of value. So I guess this one. But why should have the same dimensions as this? Okay. So I guess we break there again. I guess here. So the size of x's is 51, of the y's is also 51. So we should be able to do this. Okay. Ah, yeah, makes sense. Yeah, that's why I wanted to have line space. Because now the value of... No, it's still 0. Which is entirely wrong, right? Because the elements must be counted. Which means... I need to rethink this, and I need the maximum amount. I need my... sample amount. But I don't like that. I like it better with like... what is the English word? Let's check this. German word is Auflösung. Resolution. I like it better with a resolution. Resolution. So let's stick with that. Start x and x, which will be 0 to 5. Then we do samples. And samples, which will be and x minus start x. So this is our length, and then divided by resolution should give us the amount of samples. Then we iterate till the n samples have I++ again, till n samples, and then in here we don't directly do I to string. Let's actually get that out there. We have let's do it IVO, I think, and that would be I by resolution, I think. Do the same here, and then IVO there. Oh, interesting. Yeah, here we want that, because that is with what we want to sample. Here, though, we don't even need that. We just want the samples, because the correct x and y value will be in this. So we just go over the samples, and if this is correct, we need to check. So I want a breakpoint in this line. I want a breakpoint in this line. I'll fix the music in a second. Okay, so ival is 0. 0.1, 2, 3. Okay, that's great. So that should work now. It does. Great. Okay. Yeah, there we have that. This will be like the weird jump, right? Because I mean, it doesn't matter if it jumps like that, I think. If I increase the resolution now, it will be even smoother. Does it get slow at some point? I mean, these are so many points now, right? It takes a while. Okay. I was just thinking like, how can it still work? Um, 5%, that would be 1%, so we'd want a tenth of that, I think. So this should be fine. This is still a lot. Let's stop this, reload that. Yeah, let's wait that out maybe. Oh, it's so broken. Yeah, break this and do it again. And close that, please. And then for that one, please also close that one. Okay. Okay, great. We have a graph now. That's something. Let me go P and turn the record. Did I turn it already? I think I didn't. Let's go one down with function. And then, okay, this already takes a moment, but it's fine. Okay. We have it, so we'll use the BRB screen. Be right back. I wasn't sure if I actually started the music, but it's just really quiet. Okay, what is next? Looks like this, right? Okay, I think the smart thing to do next would be to do the interpolation for the interpolation. Wait, is the parent function also called interpolation? Time to ask the dictionary. How is it called in German? Uh, is it? I think it's called like that. It's so weird to like type search something in German and then I always try to speak it in English though. Yeah, I think that's fine. Okay. So then let me grab this. And find the right thing in ChatGPT's history. Validate DF. Oh no, that's another thing we need to do. Integrate. Oh, integral. Integral is the right word, not interpolation. I want the integral to be shown because that one will show me the actual spread. Okay. Let's define a function for the cumulative density function, CDF. Integrate values where given x. Oh, you can't see, right? No, you can't. Oh yeah, just go over that and sum it up. I think, or maybe, I don't know. Should I think about performance here? I guess not till it is a problem. But I could think about if there's just a library that does that for me. So I won't need to do that by myself. Last time the library searching did quite a while though. This can't do it, right? No. Let me grab this then, and then we search for TypeScript. Integral and calculator library. Things also that I where is it? Here. I don't want to count every single time. So it would be smarter to like generate this once and then just look it up. Which I might do at some point. Which means that if I do like big F, oh, I'm not sure if that's valid. Which that would normally be the oh, it seems that works. Okay. Which is usually, like, at least in Germany, the quotation for an integral or the parent function of f. Come on. Oh, where is it? German keys are the best. Okay. Keyword layouts. Oh, I could just have returned an empty list. That would have been faster. So we do this. And then here, when I generate one of the things, I just store it. So I have like my resolution. So I do it like for 1, then for 2, for 3, for 5, for 6, and so on. And in the for loop, whenever I want to have a value, I just have like lookup something like lookup table get, and then I put like the 1, the 2, the 3, and only if this is like not existing, only then I do like the sum up for next value, something like this. So in the for loop, I basically generate those values, and by that I don't need to recalculate them every time. I should do something like that. And then only the first time takes a lot, and afterwards I have the lookup table to do the calculation. That would be kind of efficient. And if I do it like that, this section at some point will be super fast, right? And then also if I do that, the any library that I would find wouldn't help me anymore because I couldn't use it in the same way here. So there's just no worth with it. Worth for it, I think. I'm still checking something here though. Just off screen. Integral of, okay, that's just math stuff. That's not sampled. And if it's not sampled, it doesn't help at all. Nah, let's just implement that. Why not? Just this rate. It's actually just that. I think. Oh, but I should switch between the here it does not make any sense to have a loop. Okay. Before I do this, do I really want to get rid of amount of percentage here? Because I think that would be smart. It's making it so much worse. The only advantage is that if I return this sample point thing later on, sign crypto. If I return the sample point somewhere, that would already be valid in some way. But that's it. Okay, let's do cleanup before we do that. This becomes point. This can leave. This becomes number. Actually, do I just want, no, I don't, we do that manually because I want to make sure that it's correct. Is point maybe too unspecific? Difficulty point, graph point, difficulty graph point, could be anything. It doesn't matter. We can stick with point because we decide from where we import it and how we name it outside of this. Interpolation type can stick like that. That comment's still valid. These three all become point or points. This will become number, same as that. And then we don't need real x anymore. We can just do x. Though these are axes. And these are sample axes, sample wise. Then this can go actually. as well as this. I think no mapping is needed anymore. Is that true? No, we still need we still need this. We don't want the entire sample point in there. We just want the x and y values separated. Okay, so that should be working now. Return is numbers. Oh, and then return can actually be point. Wonder if there's a nice way to merge these. Oh, this is axes. Y's. Merge in the sense of like I have the y's now, and why can't I assign that? Oh, because it's any and not number. I have the y's now, and in the end I want to combine them, right? So I actually would want something like axis, I don't know, point axis combined with y's, you know, in one thing to have the points that I want to return. Here, point. And I could just iterate again with a for loop. But we can also just ask. That sounds like something to me that ChatGPT could know. How to merge two TypeScript arrays into one array that has x and y per element from these two arrays. As two arrays, x and y. Let's see. Yeah, okay. That's just doing the same. It's like the manual thing, so maybe there is no cool way to do this. But we can ask, is there a cool way to do this? Zip. Interesting. With Lodash. Is there another? Okay. Yeah, I'm not sure if I like this more. Am I sure that they have the same size? Yeah, I can be 100% sure that they have the same size, I think. So I could actually do could maybe actually do axis map and then x index and then map this to like a point, right, which is the return value, and that has x as x and y as y's on index. And then maybe here we do new point. Point is an interface though, right? Okay, so maybe you don't do that. So what's your problem with this? Void is not assignable to point. Um, 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 um. What about this? But map should return something. Maybe because I don't return anything here. Return, return, return. Expected close. Okay, let me switch the record with that. Okay. That's a bit cleaner here, I think. Which is nice. I mean, this is still bothering me a lot. But safety first. And I'm fine with that. I think I can be sure that this always works. I hope. Okay, so then this also becomes something nice. Oh, I don't need to name this. Okay, so we have the axis as input. The axis as input. We need a for loop, I think, for all of them. So, let key in axis. And then in there, can I combine this? Read only const something. Wait, it's a class, so if I initialize it, I think it will be, it has the default value. So how do I want this sampling? I think I want to do the same thing here with like I define resolution, because I wouldn't know how many points I will need. So I again would have the sample resolution. And then maybe I want a common place to set them globally or globally? Global. Globe. Global. What the fuck? Oh, is it global? Globally? Come on. Global. Globally. Okay, makes sense, makes sense. Maybe I want a common place to set them globally. Oh, it's quite late already. I should sleep soon, so I can actually do a lot tomorrow. I want to do speed running tomorrow and try to learn Jedi Survivor speedrun. And then when I'm burnt out on that and unhappy and angry, I want to continue with this afterwards, I think. But with like a break where I cook or something. But that would be the plan for tomorrow. Do like get like one run going, which I don't know, if I try to find it and stop, pause, and go where the other run is going, I don't know, maybe it takes me 3 hours. And then I do it once again, takes me maybe 1.5 hours. Which would be 4.5 hours. And then I do an actual run. Oh, I would need to set up the live split stuff. I don't have that yet. Maybe I just don't and just time it somehow differently. Or just start and stop. And then I do like a real run. I hope that the real one will be like around 1 hour. That would make sense, I think. So then maybe after, I don't know, 6, 7, 8 hours, I would have like a real run. That would like be a nice start, and then from there I can just in the mornings, if I don't feel like coding, I could just do one run and see how quick I would be. That's the idea. So basically I want to learn it tomorrow to be no, this is at least needed, I think. I want to learn it tomorrow to be able to play it at any point if I want to then. Okay, to set them globally, to set all sample resolutions. Oh my god, why is my spelling so bad today? All resolutions globally to the same value. Okay. So we have that resolution now, which is read-only and cannot be changed. Which is great. And this we can use now in the same way that we did here, there, here. Oh, step size or something is, I think, how this would normally be called, maybe. Do we want to do that? Is that correct? Where do my values come from? I always go from like 0. Const. Oh, well, yeah, if I interpolate here, I could not start from 0. Right? That's also valid, to not start from 0. Okay. But that's not nothing I would do here for now. I always go from 0, I think, so there's no reason in not doing that. And if I sample this way, there would be no problem in like putting in the 0 value and I don't know, 5, and then I can just subtract the lower from the bigger one, and I have the difference, so there's no use in that, I think, here. I could just afterwards do something like f from 5 minus f from 1, and that would be the correct integral between 1 and 5, so I don't need to worry about that, I think. I will always start at 0, and I will end at my current x. And I think I want to do this separate, so maybe I put that in a separate function in this loop than the function that just does one value here. And then I can also have that instead just this one, which I could also do here, but I think here it's not worth it, right? Yeah, because this works on sets, on arrays anyway. Let's do that, actually. Let's actually do that. So we have another f that differs in just getting one number. And also returning a point. And this one will always start at 0. Go to x, take the resolution from above, and then I do n samples, which would be start by end by sample resolution. And then I sum up I also don't like that I mix where I put semicolons and where I don't. Anyway, 4. And now here I need my sample rate. So I smaller than n samples. Oh, I think it must be this, right? Because earlier, I don't think so. If I have a 5 here and resolution is 0.1, the 0 will be a value 2. And that's why I then would have not 50, but 51. So that should be correct. N samples resolution, n samples I++. Okay, and then here it does this, which is weird. And it calculates that with h. H is this minus that divided by this. So if I multiply with that and divide by that, yeah, that should be the same thing. So I can just take my sample resolution here. And do sum plus equal this f of I times that. Is that correct? And then the spread doesn't make any sense because I will just take the first element. That's not okay. Of course it's not. This would be correct, I think. Is that right? Duplicate function implementation. Wait, so I can't name them the same even if they have different parameters? No, stop that. I like this. Why do they multiply it with this? Does that make sense? Yeah, it does. I think. Okay. If I draw, right? If I draw. Do we need this still? Do we have space below? We have space below. Okay. We just draw below. So how does interpolation work? We have this, we have like that. Then we have our sample points. And basically what we do is we act as if, oh, I did the wrong thing for this, I guess. I think normally you act like all these things are triangles. So, oh, are they triangles here? I have this value, I add it with 0. Then I have this value, I add it with 0.1. Then this. So basically, oh yeah, this is how it's done. Right, I remember now. Or maybe not. I'm not sure if it stays below it or above. Okay. Math has been a while. So what we do is this. This is our approximation. That's why we need to, and to get like this area, right? Or this area, to do that we need to, we have like the height or f of x and x, and to get the this we need to like x times fx, multiply that, and this h here is like the height because it's the x value for this, which means that we need to, because our sample rate is our difference, so x is for us is the sample rate. Because of that, this is always our value. We need to multiply with the height, so that's why we have I did press space somewhere. I have no idea if it did something. Okay. Yeah, so we do that interpolation stuff there, which means this should be correct. And we just sum up these things, and if the sample is small enough, that's close enough to the reality. Which means that we don't need this. We have that now. Instead, oh, but I need to like change the naming, I guess. How to call that? Should I call it sample points? Sample points. And then this is sample integral points. Sample integral point. I mean, that would make the difference. And this would be sample points. And then I also could have, just for simplicity of usage, have sample point. That would just do sample points, return sample points of 0. Is that always valid, or do I get problems with that? I think that's always valid. And if not, I have like a single point of error which I can find and do something about it. Which means that this can now be sample point, which is a bit easier to read. And then here we do sample integral point for axis of key. And then add points on point that we return points and we push back x as axis of key and y as no, it does already give us a point, so I don't need to do that bullshit. I can do this. Okay, let me turn the record. Okay. Oh, I need to sleep soon. But this feels like so much progress. I want to finish this. Okay. Now with this sample integral points function. Okay. And then now I want caching, I think. No, let's first think if this is actually correct. We sum up everything for every point, so we do all of that each time. So if we would have another color here. Also, it's so much more fun having this for drawing. It's so good. Instead of like doing some ugly stuff that doesn't really work in GIMP. I mean, it's at 33% now, so that's not even too bad. I didn't even need to chart it or anything. So basically what we do is we calculate this, okay? And then we're happy that we have the value now, and that's the value that we push in here. Then we think, oh, we need the next one. So what we do then is, okay, let's pick another color. What we do then is, okay, we calculate this, and we return that as the value. And then the next time we wait with blue, we calculate this, and this, and this. And that's just so much waste, where we could just keep the values that we already have. So one way would be that when I sample this, I here just check in like a lookup. Do I already have X? And if I have, I just return that. That still would mean that for each thing, we calculate the steps once, which we also would need to do. So instead of like doing this and summing up, we could just go in here and sample here, which I don't know if this is actually worth it. So if we would have to look up here, I don't know how this thing works. I need to check that later on. Maybe we do just like that, possibly. I don't know. Look up. What would the lookup here be? And would I still have both? Also, these steps will not necessarily be the same depending on what the endpoint would be. So this lookup might do nothing. I think that's not worth it. Calculating that once should be fine. I can just know that here's potential for improvement. Potential for optimization. Do a lookup table for all the the in between are there two words? Between steps, because also I want to have lookup for this too, so that wouldn't matter then anymore. Okay, let's check how lookup works. And by check I mean ask, because I have no idea. TypeScript, how to do a lookup table. There is a lookup table, okay. No, there's not. It's just a map structure. I see. Because map structures are hashed or something, I guess. So let's define here. Type look up table. Equals. Wait, that makes sense. How would this be? No, that makes no sense. Oh, this is now a no, that's just one. Maybe. I don't know that nomenclature. Using a map. We using a map. Set on and get. Is there? Oh, is already the comparison in there? Maintain the order of iteration. Map must be more suitable. If you need to advance operations or need to maintain the order of insertions, we don't. We really don't. How can I do the first with a type def? No. I want a type def. Oh wait, it is like that. I'm just bad. Interesting. I don't know why this works. I would have expected something like number this, right? So now it's an array, but it wouldn't be an array, right? It's just an object with... Yeah, okay, I just take that. I don't know enough about the JavaScript, TypeScript typing in there to care. Oh, you didn't even see what I looked in ChatGPT because you saw the other thing. That's fine. Okay. We now can have lookup tables, which we will use to have evaluate lookup and interpolation lookup. How do I instantiate it like this? Relation lookup, function lookup, I think makes sense. Okay, and then in the interpolation lookup, I check if this. Wait, how do I use it? Okay, those things. Also, I can remove that again because I think that's clear now. But this is just arrows, so that's worth nothing. Lookup. X. Oh, wait. It's definitely this dot, but is it actually working like that? How to check if an value is set? I meant in the lookup table. Has own property. Okay. Oh, I can show you. So I just do this with a key. That should work. No, it's time to go to sleep. I don't want to. So much progress, so much fun. I don't want to stop now. Okay. Has property X. If has property X, this, I don't know if this is like more efficient or if I should just get the value and check the return value. Maybe I should ask that. What happens if I just get the value? If you attempt to access a value using a key that doesn't exist in the lookup object, Java will return undefined. This behavior is standard in Java. Here's an example. And this example will be 1 because Apple undefined because grep is not in the key object. It's important to handle cases where the key map does where the key may not exist, potentially error code using has one property, or by checking undefined. Okay. I think checking undefined is fine, right? Is just checking undefined okay? Because in like, I don't know, C++ null pointer exception, stuff like that, that's not a comfy way of doing things, but it's nice if it's okay, then it's like perfect for what I want. Checking is value undefined is common, okay. Common and valid, I take that. So instead of this, we actually do point. Oh, it actually has points in it directly. Please, that makes it even better, even easier. Let point cache. Let's just call it cache. Cached point. cache point be this at x, and then we need to make this lookup table at points. Okay, and then this can be point. Why can it not be undefined? If I just return this now, will it complain? It will not? Oh, interesting. I thought undefined would be like a type. Like null, like null. Yeah, like null. So this is not type checked then somehow. Okay, weird. If it's not undefined, then we just return hashed point. Else we do all this. New point. Which also means that this can also be const. I have no idea if const is actually an optimization here or not, but I don't know. It just feels good. Point. Same as with like always using types wherever I feel like it could be helpful later. If I change something that it just still works. Because this assumes this to be a point. If I don't do this here now, it might fail at some other point, at some other location later. But I guess here it wouldn't be needed because at latest is will be checked here for this return type. So I think that's entirely unnecessary. But I don't know. I don't mind having this. And then directly when reading this, I know, okay, this returns a point. I think this is so nice when reading code, when you can just see the type of things. Okay, so we have the new point, and then we do this dot interpolation lookup of x b new point, and then we return new point, and now we have caching. Okay, and then here I think we do the same thing. Oh, here it's a little more annoying because if I would want to do it here, I would need to iterate over all of these, right? Which would mean that and I don't know if this will be faster or slower in the end. It's fun to do, so I'll do it. That key in axis. And then for these, we check if no, we get the hashed point from a function lookup at axis from key. One thing that is bad here is that because our keys are numbers, I could do this and not realize that it's wrong at some point, but we'll find those bugs, so it's not the worst. And then if hashed point is unequal undefined, I mean, that would be fine with the caching if I don't do it like this, but move this actually in here and always do the sampling back and forth with this getting the element. So basically I have this as a function that uses that, and then I can do the caching for each element. Because I don't this here now, I can't just return here, right? What I could do if it's not undefined is I add it to our return wise, but then the order gets fucked, so I don't want that. Which means that I would need to add dummy points and replace them later. What I actually could do, that would keep this nice and clean, or cleaner, more in the way this function wants to be used. I could just check them all and just say something like are all cached. I'll switch music soon. I'll just turn it actually. False are all cached, and then else if any is not cached. Actually, that should be fine already. So here then I can say wise pushback cache point. Oh no, I actually need that. And else I do all cached false true. So if any of the points is not cached. Oh, this is not the return though. So let's move this back down. And rather we do that return point array empty points. No, return cached return actually. Cached return. And then here if not should I do it like this? Because I fear I don't know how typing I only know that typing does stuff if you don't use enough of equal signs. Let me turn record now. Okay. So is that already done? So basically what I could do here, I want to get all cached values, which means that I say, okay, all children are cached, right? Are all cached. So, and then I do checks, and later I say, okay, if they are all cached, I should do it also like that. That's better to understand, I think. All x are cached. So if all x are cached, then I just return this cached return that I just built up. Which means that I go through all axes, get the lookup value. Let's check that I did it right down here too. Here used ax. That should be right. So get the cache point. If it's not undefined, so it's not cached. All x are no longer cached, and we can break the for loop. I hate that I sometimes use semicolons and sometimes not. And then I can break the for loop. Early return, early break. Because we now recalculate everything anyway. So we have that early break. I actually would rather have it more visible. Okay. I don't know where to put this. Maybe here. I don't know. Okay, so we break them. This will then be false. So we won't go into this, and we do the full loop. If we never go into this though, then every point was defined, therefore cached. We added it to the cached points and can now return the cached return and have everything without calculating at all. And then if that's not the case, cached, let's actually do it like this to have like more consistency in the naming. Cached points, okay. And if that's not the case, we do let new, no, this is actually const new points of type point, and that will be this. And then here we do new points for each point, and then we do the function, oh no, function lookup of point.x and assign point, and then we return new points, and now that should be cached too. So now after we do the calculation with this algorithm and we get the points, we just put them all in the lookup. So if we ever again want to use any of these sampled points here, and we sampled them already, and like the full set works like that, then it will work. Which is kind of a weird way to implement it. Instead of going stepwise with a sample point and then caching each individual, I think this is okay to have at least this function be used that way. And then I guess this might be some efficiency in doing this rather than doing that individually. So I think this is better. And then I could make it more complex to like remove everything that needs to be sampled and only sample the new ones and then put everything back together, but that would make the code more complicated, I think, without a huge benefit. So yeah, that should be fine like that. So everything is cached now, everything is working. Each section is self-contained, has its lookups and whatever, is efficient, hopefully. Wait, where did this lookup come from? It broke our thing here. Okay, so all of that is correct now. we need to do the difficulty graph thing. And I think this won't even be a difficulty graph anymore. We just rename this entire thing to, we just do graph, I think. Sectioned graph, maybe sectioned graph. And then we have this ordered from 0 to high value. That should still be the assumption, in my opinion. Here, we use the same thing. Sample point. Yeah. Sample points. Sample points. Points. Those are axes, returns, point, thing. Yeah, everything should be renamed, and we will do that. Point. Oh my god. Okay. Sample points. Axes. No longer useful. Receive. We find the section. Found section. Oh, that's actually a good thing here, because I can just, you know, put this in here. Oh yeah, I like that. So afterwards, if I no longer do this, it would be illegal to use it otherwise, but I don't use it, so it doesn't make any difference. It doesn't matter. This is more explicit. I like this. So we will do this here too. Okay, where were we? Yeah, that optimization is irrelevant, I think now. Don't even want to note that. Okay, we have this section or undefined section find. The same stuff here is true. Found section. We take the first section, that which end point is after the wanted x or equal to it. Found section. I'm not sure about this yet, because possibly if my function is not a PDF yet and I want to rescale it, I need to extrapolate, possibly. I'm not sure how to design that. Do I maybe need the next lines in the case of rescaled of non PDF graph that needs rescaling. Okay, illegal. Okay, we push back for keys and X. Oh yeah, because we do them individually. So if we use it like that, we actually never ever use the combined thing. So there's no value in that then, that we do the optimization like that, but fine. Again, I could make this more complicated and collect all that are in the same section, or like group them section-wise, and then pull them together. But that's not worth at this point because this is potentially not slow enough. And you don't optimize where you don't need to, right? So we just push back our sample points, which will be points. Why should this actually be? Oh yeah, this is points now. This is great. Sample points. And then we need inverse sample points. Inverse sample points. Which also takes wise number array. Find array. Return empty. Okay. Should work. Constructor to do at the calculation of the whole integral here to do the scaling afterwards, right? This also means that we build up huge parts of the lookup table once, I think. If this is something weird, oh, it should just not be null. Okay. Or 0, not null. So this must be bigger than 0. Okay. The first section must start with x. Do the compares work. Do the compares work. Oh yeah, because this is the weird percentage thing. They do work. Now, can it be the case that one of them is percentage while the other? Yeah, I don't care here anymore. We just assume that. We must start with 0. I note that this loops for one less loop than the sections given. Why? Is that even true? Isn't that a normal loop? It loops for each section once, no? I don't think this is special here. It's just 0 indexed and then length -1. That's whatever my past self thought there was stupid. Okay, and then if the section end of the first section is not equal to the start of the next one. Okay. The thing is though, if there's just one section, this should not be called with just one section. Then it breaks because there will be no second section. If it is 1 though, then this together will be 0. And 0 is not smaller than 0, so it will do nothing. Okay, so it's fine. And works. So we have the check, we have the exception. I mean, they can actually be just separate checks here. Make it easier to read. And then here, the scaling would need to happen. So I would need to do... Oh, that is actually very interesting. Because... Well, this is true. The combined function will have its own integral. And that one... we'll have to calculate all from the left to the right. So if I want to do the inverse sampling, I need to do one integral. I can draw that. I should draw that. So how the inverse sampling works is that I want to roll a dice. I think the surface just died. No. Okay. Let's see if we can restart it. It's starting again. Oh, maybe I should hide things here though, because I won't know. If I switch to this monitor, will you see that? Can't even check. I mean, I could be just quick. Oh, I could check on my phone. What will you see if I do that? Which would be this. Super safe mode. Okay, let's try this again. Okay, so you can see that screen. That's interesting. Hopefully it did not crash. It go off the tablet in a way that my drawings are gone. Where's Steam? There. But I guess it needs to open first. Come on. Ting. And it's so slow compared to another PC or like my PC, where I wouldn't recognize that back then when I only had that one. So slow. Now it did open Discord, or at least open the window. Did not really open it yet. Come on, give me the option to close things. Oh, the ghost thing is again there. Yeah. That explains things. I really don't understand when it's there and when it's not. No, just shaking the tablet, turning it left and right, hoping for things. And now for some reason it's working. So let's open that. Let's open Steam. Okay. Just some more moments. No, Steam is updated now. Why do I even do this? What did I want to do? Did I want to show something, or what was the reason? I want to go to bed. Why do I do this? It's so slow. Okay, Steam is gone instead of open. Okay, it's loading. My god. Okay, Steam is there. Let's pin it to the taskbar to be quicker next time. And then this should be enough to do the WordPad stream, which should open WordPad on that. Yeah. Okay. And then I can do this. I should be back. It's not back. It should be. But it's not. Oh, because I see. I don't see. This, maybe? This is so bright. I guess possibly it must be on the same... Oh, I can't pick it. Why can I not? Oh, it has it now. What? So working again? I guess working. Should have not trusted the battery to hold long enough. Oh, I can also edit that down there. No need to even go into the settings. That's great. Okay. With that, little derailing. Let's get another graph. So we have another graph. What I want to do is, like, in the end, I have whatever function, and I want to know what difficulty should I pick. So what I can do, because this actually here looks like this, if this is a CDF, cumulative density function, I have the values here start by 0 and be guaranteed to be at 1. And then what I can do is roll a dice, which will give me a value between somewhere. Oh, this is also not valid. This works because the CDF is always increasing and like statically monotone, like this. So if I have this, this will have a value here for the want difficulty. So let's say this is rolling 0.6. I don't know, maybe it's a 5, whatever. Then I can like calculate this cumulative density function, integrate till 0.6 is reached, and then pick the difficulty value. So with that, I go in like this direction, that direction, and can pick that value. And that's what we do with the inverse sample points. And for that, I think I need to do the interpolation, right? So I roll this value, then I use a sample integral point thing here to get like the correct point. And then I can do stuff and return. Actually though, I think the inverse sampling works different. So maybe I only use and need this for plotting and for this check. We can name this, by the way. Inverse interpolate something. So that is complete. We could now do like a sample integral points function. We could do that and implement that here, which will work in a way that I again iterate over the sections, but each section that I'm not in, I'm not using the iterate function, but I just pick the integral of the entire thing. But later on, there will be the case where I will use subsections of things. So I would want later to have, oh, can you give me a color value? Thank you. I would integrate something like this and want that value. And there would be a problem if the first section would be till that, and then I continue. And then I just say something like, well, I pick this entire integral and add that part. That wouldn't work. So this only works. Oh, it would work by the same thought that I had earlier, which would be that I could calculate this point and subtract. So okay, we can ignore that again. Okay, we can ignore that. If we can ignore that, that means why do I actually have this, by the way, not here where it belongs? This means what we won't want here is that for each section we like get the integral point of the end point once. Oh, and we don't even need special code. It will just cache it because that's just one thing we cache. That's good. I like that. Yeah, it will use this and cache it. Okay, great. So that means we duplicate this now. This will take the x-axis values, sample the graph, interpolate it, and return the y-axis values of the sampled interpolated point. Turn the, and this is actually wrong at this point. We'll turn the sampled interpolated point, return the sampled point, return the sample graph and return the x value. No, we'll return the sampled point. Okay. Sample interpolate point. Sample into integral points. We get x's, we get points, we do the same thing, but here I could actually also make sample 1 point and multiple points here and not have it combined. But yeah, it doesn't matter really. But it means that we don't do this find section stuff. What we do is we have a for loop with let section key x key section key in this this sections. Okay. And then in here, if I would be able to press the right things, if now we take this condition, if this condition is true, we need to actually get a value. Else, actually I want this inverse. So as long as the end, as long as the section end is smaller than the x value, this section's section key, as long as that's the case, we want, actually let's get this section be this, and then section, yeah. Okay, now we have the section, and then if we have that, and then we need to sum everything up still, right? So let's sum number be 0, sum be 0, sum, and then we add the section dot sample integral point of section dot end dot x, and then we take the y value. Else, if that's not the case, we sum the section dot sample integral point of the x's x key dot y. Is that true? Yeah, this should be true. What I will do though by that is that I will try to integrate from 0. And if I try to get like 0 as a value here with a polynomial function, that value will not be 0 in before. So if we have our sections again, my algorithm would currently result in something like this, right? That would be the polynomial section, like this red one. Because the polynomial is laid through all these points, it will basically have this extrapolated part. And when I then do the integral over that, it will count these things with like the boxes, which I don't want. I want everything before that section to be 0 and then start. Which means that what I think we should do in the algorithm here for the integral, we don't start at 0. We always start at this dot start dot x. And that I think should be then the right thing. Because then it will only sample its own section and not confuse other stuff. And we should also check that end is never after end the same we have somewhere else. Yeah, basically this check that we cannot be outside. We actually would need that too here. Because outside it would still be 0. Like if this x is too big, it should just return 1. No, it should not return 1. Let's check that just to be safe. If x is bigger than this dot n dot x, I'll handle the music in a second. This is illegal. They use comma or dot comma. We can not integrate outside of the sections found, or x is smaller than this dot start dot x. Actually, that's a check that could be in any of these, honestly. This will use this directly anyway, so I don't need it there. And as this is the main point here, where would I check that? Actually here, I guess, where I go over all of them anyway. So I would check it here and throw if that's not the case. So now I'm sure that I'm in the sections bounds always. Okay, let me switch the record. Do I make it so much longer still? Show up. I love this record for being for being fully transparent. It's just amazing. I feel like my maybe I'm hardly hearable because my let me switch here. Did something adjust my sound volume of my microphone? Someone did. I guess it was Teams. This is how it should be. So the music was way too loud all the time. Damn it. How do I get the advanced settings? Okay, there they are. Microphone here. Settings. Okay. So what I disabled now is that other, but I had that disabled already, that other applications can control the device on their own, and they can no longer. So now it should not be able to switch the decibel of it, and it should be loud enough. Oh, how annoying. Okay, that's better though. Awful. Awful, awful, awful. Back to this. Where was I? Damn it. Oh yeah, I added these, and they should work. So the sections should be fine. And now this, crazy, that basically we just did this difficulty graph class. That isn't even called like that anymore. It's sectioned graph now. Oh, it didn't rename, said. Sectioned graph. Okay. If I do this out of bound checks, right? Oh no, I do need this check still. But I think I removed those now. I need this check still because I would try to use it on non-existing sections, so I need that. I should never be okay. This is illegal if we would extrapolate this, would not be a PDF, don't try that. Actually this is illegal. It is out of bounds. We cannot interpolate outside of the sections bounds, and here we have this illegal. We cannot integrate outside of the graphs bounds. Fluid X rhythm, yeah, something like that. Okay. For this, we go with the sections. The sections we at the endpoint of all sections. So we just take the entire integral from here. So we take this. Then we take this, and then we see where we land on and do the actual integral for the rest. So that should be fine. Right, and then for the rest we do this. Okay. Oh yeah, that's where we came from. We pick like an x here, and now with the change that we did, that we start integrating at the start of a section, now we don't no longer have the problem that these are added because we start here. So this is actually okay now and will not overshoot the value. So our sum will be correct as our x value. Which means that here now we can create the point. Not sure if we will need it, but we can do that now. Right? This is now valid. And that's our new sum, new point, whatever. So this would be the calculation for 1x point, which I think I want to have like this in case I want to ever make that a subfunction. Okay. Nice. I guess same here. Okay. Oh yeah, we don't need to do a point of this. We can just do points push. And then get rid of this. And then return the points. So now we can have the integral. Sample integral points, sample points. And then here actually it doesn't matter if we pick something that is outside, because we iterate over the sections. If there are no sections left, we don't iterate. So the sum should always just be 1 if you extrapolate or pick a value after, so it doesn't matter. Okay. Okay, that's done and works. What we will use this for actually will be that we do something like this. Sections. Yeah, actually we check that first. Set that, and then we can do this dot sections. We pick the last element. We pick its end. We pick its x. And something is not okay. Oh yeah. We don't have a singular function yet, but that's fine. Const point b point So we can do this. And then we do stuff if this point, I'll turn the record soon, is unequal 1. That's like the trigger. And if that's the case, here we need to add the scaling. And my idea is that we just have fixed values for this entire graph. Which means that, I don't know, I have like X, Y scaling here or something. Maybe just one scale value. And whatever I output here, or whatever I generate, I know that I need to multiply that with that. Which I don't know if I just, you know, have then something like this dot scale, which seems inefficient to me. Something like that. And that just takes points and scales them. And I just have that in the end of all the functions. To make sure that this is whatever I put in here, that it will work as an PDF function. Let me turn. Because what I think is happening, I'm not sure if this works, if the sections are no PDFs actually. Do they need to be? Actually, I think they don't need to be that. Just the subsections. Oh, this is loud. I'm hitting like the microphone arm. Now that the microphone is at 100% sensitivity. So the idea is that this is like PDF, right? Oh, where do I write this? I don't know. PDF. 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 I should actually make this big if I do more with that and not just in the tiny corner. Which I think I can do with this. No. This? Kind of. But it's not scaled correctly. I think I should put it somewhere here, I guess. Maybe. I should do 2 scenes. Can just duplicate this scene here, please. Duplicate. And we call this remote. Because in remote I want this. Remote full. We delete this one here. And then we have the extra screen with the window capture and that thing. Desktop, everything. Okay. And then what we do in remote is we just inverse that. So I move these. In the extra screen. Remove that one. Can I not move them in there? I can't. So I can't have groups and groups, I think. Oh no, it's there. It's just not scaled correctly. Okay, remote full desktop. Okay, this has no effect, I see. So I should actually move this one in there then. And like... Okay. That looks fine. Now I just need to remove this one. And rename this as... Rename. Extra screen. Name already in use. Damn it. Remote extra screen. And then I can switch. Yeah. Might have broken things here. Duplicate. We remove this. Cancel. No, that's right. And we reset this transformation. Desktop full. Okay. Reset transformation. Reset transformation. Okay, this looks fine again. And then for remote, I no longer want desktop full, but I want remote over that. Remote extra screen. Desktop extra screen. No, why is everything deleted from that one now? Oh, I might have lost that thing then. Annoying. This has so weird dimensions. Yeah, I guess we fix this now and then we stop or something. Is that the right thing? It is. Why is that captured so small? Oh, because it's scaled down. Yeah. Hmm. How did it do that both fit in there? Because they have different dimensions, right? No, I would actually need to... Okay, maybe like this. And then this border... should be something like that, I guess. And then I scale this up. Move in the corner. Okay. Okay. Let's see if something else is broken now again. How big was it? Like this, maybe? And then if I in that now... Oh, for this one also I want... to cut out of that. Okay, fixed. Let's start the music again. So we fixed this. Can we now switch here? And it's still fixed. Okay. I think I'm done now. Do I miss something still? Eye tracking is also working. Oh, I do want this one too, I think. Here. Oh, is it? I think if it's the same, I'm not sure if I can just scale it down or if that will be problematic. As well as this now not fitting dimension-wise. I mean, I can just cut off the top. That's good enough. So now I can actually switch and go like full screen drawing. That's good. Okay. That was definitely needed at this point. Shouldn't have that done that off screen or something. No. Okay. So with that, I wanted to go to this screen and I want to see my desktop alternatively. So you see when I look there. And then what is happening here is that we have the PDF again. but we're not sure if it's actually a PDF. Oh, I should also bring it like here so you can see, I guess. So it's something like this. And we don't know if the integral will be 1, but it must be. So we calculate the entire integral, the entire thing, and find out that is, I don't know, 7. If we now scale every result that we get, like if this would have been, that needs a new color. If this would have been like, I don't know, 2, and this value actually doesn't matter, then my idea is that, okay, if this is 7, by that I know, okay, scale will be 1/7. So this will result in 2/7. So when you get like the f of x, right? F of x will actually be maybe we do this differently. I should have just pressed back. Y will actually be f of x times times scale. So like that's the idea. So I once integrate over the entire thing, know my offset, and then scale it down whenever I get the result. But then there's also, and I'm not sure if it will work for that too, this is again like PDF, right? And then we have CDF, which is the integral, which will look like, I don't know, it's somehow always going up. And each value here, like if this is, I don't know, 4, this is 4, then that means we summed up till we had 4 together. So if we have that, can I just scale it the same way? Because this value here, this value here will have like an x, and this will be 7. It will actually be like the same 7. So this will also be that. Which means that I should actually be able to just scale everything, I think. Because that's the same 7. And if like I took, let's say we take green and we want like half of it, that would be equal to half the way. Actually, x doesn't matter here, so that's just do it like this. Then this integral would be, I don't know, maybe 4. And then this value would also be 4. But with the scaling, Can I somehow color pick? Nice. Then this will result in 4x7. Is that correct? I mean, if every value would be scaled down... Oh, that's interesting. It depends where I do the scaling. If I actually do the scaling after everything, that should still be fine, because everything below will work with the non-scaled values, and I only in the end scale the result. And with the scaling, it is a sum, right? It's like the sum over all these sample points. So I could write this as sum oh yeah, it's basically this. It's that. I need to turn the record again. So it will be the sum over y of x, which I could rewrite as sum over x by this scale. Which I could rewrite by putting this out of that, and if this goes till n, scale times n. Right? No, it would be just scale. If I have like 2 plus 4 plus 6, I could write this as 1 plus 2 plus 3 times 2. So I can take the scale out of this and have it separate. And that would still be valid. Which means that I get the same result. So I can just add the scale for the integral afterwards. Let's actually erase it. I don't think back will help you enough, or will be quicker. Okay. I at least am happy that this works as I want it to work. I trust in that now. So, after all this effort, you can just switch scenes. Which is quite nice, actually. Quite nice. If I don't switch them anyway, can I close them? I will never find them again to open. Never. Okay. This means that we actually will have an... This is not read-only then, right? It's private, but not read-only. And we go with 1. Oh, interesting will also be if the scale... does it not need to have like private let? No, okay. Interesting also will be that, what if it's not 7, but it's 0.5? Then it would be 1 by 0.5. It would basically be times 2 and scale everything up. I think it should still all work. Okay, so we have the scaling, which is or how do I call that? Normalization scaling. This graph should be like a probability density function. Therefore, we need to scale it if that is not the case. And what we did now is we full integral point. We get the full integral point, and actually if it's 1, perfect, but we can just set the scale, normalization scale, because if it's 1 then it will be scaled with 1 anyway, so that should actually work. If we just take this dot y, and then this should be normalized. Section graph. What is missing though is the normalization function, which will be scale. Can I also do these private? I don't know if I like it here or not. I think I want to keep them here, like even the private ones. And I don't know if functions can be private. Should I just void this? I guess it's not void. Oh, it is, but like this, right? Can I just adjust the points? So I do this, and then I do points at key dot y equals points at key dot y times normalization scaling. Oh, now I can't return it anymore though. Now it would be like an additional step, so I would need to do it like this, right? Okay. Done, maybe? What is interesting here is that at some point maybe I want the unscaled values. So maybe actually I don't do it in here. So I can have the values, or if I want to do stuff with it, I can just normalize the points if I need to. And have that as an option. I think that's better. Okay, so what's actually open is the inverse sample points thing. But that we won't even plot for now. So let's actually continue here next time and end with plotting plotting the new CDF with less errors, hopefully. Okay, section is no longer valid. Yeah, thank God. This feels so good. Actually, can we do this? It will stop at the wrong point, but that's fine. No, it's still working. It's just not. Yeah. Okay. No. Now we need to remove those. Okay. Mm-hmm. 0 to 5 is still true. Resolution should still be fine. So the rest should be fine. What no longer is fine is this bullshit here. So my axes are numbers, which means I directly push back the sample points. And then I get points returned. Yeah, we will stick with that record till I'm done. So we now sample these points. And those directly be data, right? And then we do normalized sample points. Point this be like sample points. How this, like this. Oh, also I'm not sure if this even works like that because I don't do a deep copy. I just copy the elements in there. I think at least. But we can try. And then do div graph dot. Oh yeah, we did do it private, which is no longer true with the change. Here. Normalize. No. Normalize points. Okay. And then for the same thing, we want to do sample integral points, sample integral points, integral points. How do I say your name? Farlin? It's so small on my display. I think that's correct. Farlin Griffones. I hope that's said right. Nice to have you in. Hope you had a great day or great start in the day. Time to watch someone else suffer coding instead of doing it myself. I mean, yeah. That's also how I watch others code. You know, like just a bit of hate watching. But no, I get that part. But it also means that I get like most of the satisfaction for getting the resolution, except if like someone in chat gives like the hint. But I don't really care. Like I take all the hints as long as I make progress. So yeah, like happy to have you here. If you have any comments or questions, just ask. I won't do too much longer, but I have like some sketches I could talk about what's going on here. And depending on your background, I could go, you know, way into detail or just say that I basically have like sectioned probability density functions here, and I want to like interpolate that and just give the sample points, like all these yellow things. And then I want to interpolate, I want to build the integral of that. I want it to be scaled correctly. And then I need that for other stuff later, because in the end, we want to have like, oh yeah, of course this is broken now. And I can't show it. Still broken, I guess. Damn it. Well, in theory, you would see the bingo board there, right? And I want to plot stuff and adjust the difficulty of things. And for that, I want to show the user how the difficulty curve will be and all of those things. Yeah, so that's where I'm currently at. Don't know why I get this error now. That's totally unfair. Which one could account to the suffering part. Can I interpolate outside? Oh, wait, that's an error I gave. I created in there. which means that our values are too big. Because as soon as you show someone else your code, it breaks. Oh yeah. That's like the general rule. Especially if it's like not the finished thing, right? You just have like an in-between state that now it's worth showing or discussing or anything, and you just think it's still working with the current news changes, and then it's just broken. I love that. But here, like, it doesn't matter too much, right? If I have like at work customers and want to show them something and then all is broken, that's not like that's worse. Here I can just investigate till I find the reason. Which means, why do I move it over here? Let's keep it over there. Let's go into the big screen and actually debug here. Because I think the only problem here is that I don't sample correctly. So my axis I should land here. I'm quite sure. This is before anything. What? Oh no, it's actually breaking here now. Yeah, okay. So it goes into the constructor. What I do is when I create this object, I once, for this section graph, I once do the full integral. And when I have the full integral, I can use that for scaling and normalize that PDF function or CDF function. So this is clearly wrong, but it's clearly right. Okay. But I mean, we can step in here too, right? So constructor, okay. No, why are you creating sections now? Get out of there. Oh, okay. No. Okay. Fine. I set another breakpoint. Okay. Let's stop and redo. What do you do, like, I guess then for work, if you were coding, do you just or do you just do it for yourself? And what like programming language do you use? Oh, I should actually add like my programming language in my stream tags, I guess, when I'm programming. Because there is TypeScript. Yeah, let's add that. Okay, why not? I could also add React. Let me turn the record because I play like vinyl records most of the time. So I need to stand up to switch music. This one is especially nice as it's transparent. Okay. We stop, we restart. We go here. And then this is correct, this is correct. Yeah. And now we go here. And here X contains 0, 5. That is correct, because 5 is our end. We should be able to interpolate that and integrate. So let's go on. This should be 5 now. Okay. We want to sum over all these sections that we had before. This section ends at 1, which is smaller than, oh, this might be, this might need to be smaller equal than let me think about this. If we have, where is it? You should see too. Okay. If we have this, and I have my section, here I have sections. The red one here, this one. And I want to integrate over that, I need to sum up all these sections. So if I would be at this point, right at the edge, which would be equal x here, I think I still want to take the left part. So in this case here, I want to have that. I don't want this line till there be added. I just want this if I jump, if I have like a step function. So that would mean that if it's equal x, I would still want the entire section from before. Which also means that in the end, if I am at 5, which is like the last one, right? Here. Instead of going into this section, where I would input 5 here, no, I would in any way input 5 there. For that edge case, it doesn't matter, I think. Yeah, because I would definitely either put the 5 over this equal in or over that one, so that doesn't matter. Which also means it doesn't matter for those before, I think. Because I go section by section. So I will take this section anyway, and if I put in the value by this one or that one, it in any case will be a 5 here and a 5 there. But like later on. Right now it's of course the 1. So let's actually break here, I think. And do one loop. So this was fine. Our sum now has a value which is close to 2.5. Which I have no idea if that is valid or not, because I picked a random samples. Where are you samples? Oh, wrong file. So we go from 0 to 5 as a linear triangle, which means 1, 5, 1, 5. So that would be 1 multiplied with 5 for this area by 2. So that's correct. Okay, so the 2.5 is correct. And then afterwards we have again one step, again 5, but this time it's a square, right? So this time the value should be 5 and we should add plus 5. So let's hope for that. We again go in here, which I don't quite get. Oh yeah, no, it makes sense. Because we're not at the end yet. We're just checking, like, is this a section, looking at this section, that we take entirely, or is sample in between? And as our value is somewhere here, we're still in the first sections. So that's correct. And afterwards, this should be 7.5. Oh, and no, I don't need that. Okay. So yeah, go over that. And this crashes. For the step function? Why? Why? Wait, why is my call stack not nice? Where? Where is the function that I'm actually in? Damn you. Okay. So I guess I need to go into integral points or point. Simple integral point. And check this. Wait. Yeah, that's just wrong. How did the one before not fail though? Let's reload. Continue. So here x is 1 and end is 1. No, that's correct. Okay, let's, and this is 0, right? And this is 1. Okay. Let's go here once again. Now x is 2. So it's not bigger. Wait. And x is not smaller than start. So this should not fail. Oh, it doesn't. Okay. We have a second check here where the problem could lie. So let's go there. And actually go there from the start again. God damn it. It's the last thing I want to do today. Just plot the stuff and then sleep. But it's taking its time. Let's see. X of key 0 is 0. Oh yeah, because we take all the points now, right? Yeah. End is 1, start is 0. Okay. Valid. Totally valid. The problem is that I will land here way too often. I need to reduce the sample rate. Oh, I think it's because of rounding. Maybe. Yeah, I need to reduce the sample rate. Else I will be clicking forever. I can't do it like that, or what? Sample rate down to .1, I think. What did I have before? Okay, let's copy that to not forget. And then reload this. And now we only have 10 steps, so that should be fine. Okay. This is also just weird. The values don't seem correct to me. End is 1, start is still 0. Why ever we do that a second time? Why is it 0 again? Oh, because I checked this every time, no matter if I cache or not. Yeah, makes some more sense. But that means that it's duplicated. But at some point it breaks. With a 0 entry? I mean, I can just give more information, right? God damn it. The record is done again, and it's, I don't know how often I turned that record already. Let's actually change that here. I gotta focus. I need sleep. Okay. We have X now, we have that, and then we want to do console warn X, this and X, this and Y. No, start X. Okay. Turning the record again and then looking at this. How was this able to trigger multiple times? Before? Oh no, it didn't. No, it did. It triggered twice before it crashed. But maybe the error handling is delayed. Okay, so what I have here is that my X is 0, but my section is 1. 1 to 2, but X is 0. That seems wrong. How can that be? This means that I'm in the second section, but input the wrong X value, which would be 0. But I don't get why it would be 0. Let's stop here again. Oh, I can't do it like that. It's not stopped there, but rather here. Okay, section is... it's starting at the wrong thing? No, it's starting at the right thing. And then second section starts here. Starts at 0. Okay, there it is. Come on. Starts at 110, goes to 210. That's fine. The x value is 5. That is correct. And now we go in here, go inside that. X is 2. This is valid. And then we do what? We start at 1. Because that is how this section works. We end with x, which is 2, because we take the entire thing, which is also correct. Then we sample. We get 10 samples. I times sample resolution. We start with 0. We're missing an offset. Yeah. There's an offset missing. It's, I think, this. So now we start at 1 and then go up to 2, I hope. Which I could check by pausing here. What an annoying error. Where is it though? Come on, show it to me. Why do you hide yourself? Here, okay. Start plus. What a stupid mistake. Okay. Stop here. I guess after reloading. Sample point this here. So what I want to know is what I ended up with. Because smaller than 10 is actually not correct, right? I need 10 to also be calculated, because 10 will be the end value, which I also need. So I guess this now is, the sum is not correct. Where's the sum? Here. There's like one step missing. No. We did 10 samples because we started with the 0 and we did 0 by that 9 times. We need n samples plus 1, right? Because we have one sample more. These are like the samples from everything, but then the start or end is missing. So this must be +1. Because we sample the 0 too. Oh, maybe we should not sample the 0. No, we shouldn't. Because it won't be anything in there anyway. We should start with 1. Because it will be multiplied with... No, it will be multiplied with something. That's just wrong. We need to start with 1 and do 10 things, and then we have these squares, right? So currently I'm also adding I'm adding like a square here with the size of the resolution and like whatever height there is in this position at the y-axis, and that's wrong. So I basically have 1, 2, 3, 4, 5, and I don't want that one. I don't want that 6th. So I start with 1 to have the first thing, second, and so on. Okay. Let's save this. Restart. And now sum is the same value again. Oh yeah, for the first it makes sense because there the value of 0 is actually 0. Shouldn't this be 2.5? How is it not 2.5? God damn it. I can't continue to hear that record. Let's just do random music till I'm done. Let's do this. Is that loud enough? I think so. Okay. Some bad omens. So how is this wrong? This is 10 samples. Starting at 0, going to 1. That's correct. Then we get a sample point. And we multiply the stuff. This should be right. Oh, this is most likely something that if I wouldn't be tired, I would solve in like 5 minutes. This new point is 1, 2.25. Nah, it should be 2.5. It should be just high. Oh, my step size might be too high. That's why it's unprecise. Let's see. Oh, I can't do that, right? I should set up that I can debug in this one. Okay. Do it again. Yeah, now it's really close to 2.5. Okay. $10,000 samples. That's crazy. Is that close enough for 10,000 samples? I don't know if it should it not be 100% correct with 10 samples? Because it's no, it shouldn't. No, it shouldn't. No, that's so fine. Yeah, it's just correct. Okay. My brain is just dysfunctioning. We have triangle, right? For linear. So how we draw this is I think we don't draw them like this, right? But we rather draw them like this, I guess. So that's why this black part on top is just missing. But I don't get the last thing here, actually. I think that's not how I'm calculating it. Because I take, let's do only 5. 1, 2, 3, let's do 4. So if I have, if I have 1, so this would be dot 25 dot 5 dot 751. So this would be my step size. I would have 4 samples. Because I have 1 minus 0 divided by 0 to 5. Okay, I didn't take that one. 1 divided by 0.25. 0.25. Okay, that's 4, right. Just wanted to check that. That's 4. So if 4 samples, we do iterations 1, 2, 3, and we don't do 4. That's wrong. That is wrong. Because now 4 is not smaller 4, our sample size. So I should do like this. And then offset here. This is correct now. Whew. I mean, not yet, but soon to be. And then this is also just a standard for loop. That's easier to understand. I think it's better this way. Not sure. Okay. Now we also go back to this. Reload. God damn it. Why is it too much now? Okay, now it is doing the calculation as I expected, at least. I think. So I'm getting this point, calculating that. Getting this point, calculating that. This, calculating that. This, calculating that. And I do that 1, 2, 3, 4. So that's what I'm currently doing. So at least the algorithm is doing what I think it does now. And now the question will be, do I want that, or do I always want to stay below? Did I ask in the beginning for lookup? No, it seems not. Oh, this is for integration, right? Okay, here they don't add +1 to the I. If I don't do that, then I would still do this. No, then I wouldn't do it like that. Then I would start here. And this would be my 1, which has no value. This would be 2, 3, 4, and I wouldn't have another one. Which I could draw differently, right? I could draw it also and interpret it differently. I could say, okay, I draw it like this for the 1. And then I draw it like this for the 2. And like this for the 3. And like that for the 4, which would be correct. Because this also means that if I have an offset now, it still works. Because then this value has actually influence for that size. So I just need to think it in the other direction, and then it's actually correct. But then I'm not sure what was crashing before. Anyway, so no, not that one, this one. So it is correct. With I. And this is fine because so much is missing and we get closer when we do more precise. Okay. So all of that is correct now. Do we still crash? Because I feel like we just undone what we did before. You know, just go for it. Tell me if you crash. You don't crash. You do crash. Okay. This one. Not even that one anymore. Huh. Okay. Okay. Let's run this again, but look at the console. So we have this section 1, 2, we still get the 0. Shouldn't that be fixed? Oh yeah, that was what I did to fix things. I added the offset, or the starting point. This was the change that was relevant. So I no longer have an idea how I could call this without the correct value. Because this will be 1 plus things, and they cannot be negative. So I guess I just need to break there again and see where I'm coming from. X is 0. Who is doing that bullshit? Oh, interesting. Sample integrals. Yeah. So we're already over that arrow. That's great. That's great. Okay. So this is the next one. Oh, the thing is that we restart this loop where we shouldn't. No, we should. X is 0. We won the first section. Sample integral point does not fit because the endpoint of 2 is further down the road. But it's taking the wrong... Oh yeah, it's taking the wrong section. It should take the 0 section again. This one should be taken. But it did skip that one. Oh, because I don't break. I need to break after this. Because then we're done. I just try to continue calculating stuff, adding stuff. We're done after this. We found the section we're actually in. Oh my god. Progress. We're back to this after several hours. Okay. That took its time. Let's add more plots and see if things work. So I guess I can just do this several times now. Normalization sample points. Normalize. Okay. Actually, let's see. Are they just over another, maybe? Maybe they are. So I guess then we do more charts, but with less bullshit in there. Oh, there they are. Okay. Now I'm not sure if I actually did reload correctly. No, it does not work like that. So we want 4. We want this to be normalized sample points. And this 2 integral. It looks wrong. 20, 40, 60, 80. What? This is correct. This is so wrong. So wrong. This should be 5. What does this do? Domain padding. Why is there... Maybe there's a minus somewhere there? Padding 15 pixel. There's no minus. But the y values should not be broken. Let's see. Oh yeah, this is just wrong. Hmm. Let's reduce this sampling rate significantly. Okay, reload. How is that happening? That's not possible, right? Or except if the normalization did stuff to it that is weird. So let's not do these this time. Okay. Now they are correct. So the copy did not work actually. Which I guess means that I just do a copy then if I do it like this anyway. Why not? Points, point. Normalized points. Return normalized points. Points, key points, and then I do normalized points. Push, I guess, with oh. Now that can actually be like this. Okay. So this normalizes now as we want it to normalize with a copy, which means that this is what we want. Nearly. This is what we want. But it is still wrong. Not this though, this is correct. Interesting. From 1 to 2 actually. This should be straight. Oh wait, we do need to increase this again. 1 to 3. God damn it, it's so slow already. You know, it just takes a moment. I mean, this is just for the graph, right? So that doesn't need to have such a high resolution as the other one, especially because this will be the points, it will be so many points. The other one I want to have like in full control. Oh, come on. Try once again. Because if I do this with percentage, oh yeah, the problem is that this resolution is not necessary if I have non-percentage values. So here, it's actually nicer in a different way, but okay, it's reasonable time frame. So I wouldn't need to do it like this here. I could do higher resolution because we only have 5 steps, so I could do 0.1. That should be fine too. But okay, that's looking better. Parabola step is steepness here, then it's linear, and then it's doing the, you know, this shit. If the value here is 65 or something, I don't get why the scaling does not work. So we need to stop here. So that's nearly 65, which looks like it's correct. For position 5, okay. So that looks right. Wait, why do I multiply? Oh yeah, this is 4,000 and not 4 point. Okay. I think I don't want to store that way, but rather do the division there. So I don't have like an even more uneven number with like more rounding problems. So we do it like this. And then stop that one and reload that one. Waiting. Come on. There are my graphs. Okay, 65. This must be 1, which is great. Hi Morden, nice to see you. How are you doing? I'm close to stopping because we nearly have success. But I'm happy that you were dropping by. I mean, I will anyways give a rundown on what happened and is working or it not, or is not in the end. This is a banger. Oh yeah, it is. Okay, that is stopped. That's good. Let's reload this. Nice graphs. Thanks. You wouldn't believe how long it took to make them. This is still smooth enough. Okay. Okay. So is this working now, actually? I think so. Okay, here's the rundown. Tablet, okay. What I'm doing here is I have a graph that is sectioned into these red parts, and I have the sample points that I put in, and in the end this should be the difficulty spread. So if you see this, it basically says that a difficulty with difficulty value 1 should be appearing with percentage value, I don't know, 8% or something. A value with 2 should appear with 15% chance. And then, you know, I do a lot of math and calculate stuff so that I have the integral of it. And then in the end, because what I do is I make a bingo board, right? And I really over the top designed this, which makes no sense, but it's fun, right? In the end, I want to know if this field is assigned the difficulty value of something, which actual value do I pick? So what I do then is this inverse interpolation, and that's the next step that I do. I roll a random value between 0 and 1. I do the inverse integral. So this thing, so I roll, for example, the 0.4. I'm here. And then I know I need difficulty 2.7. And today's progress is to have like all these graphs. And you see like this is unscaled, this is a scaled version, unscaled, scaled version. And my brain is just right now. But it was a lot of fun. So I have like a really math heavy class now. Or several classes for like the sections, and then I sample the points or interpolate the points. I do all this stuff, and then I have the entire section graph, which like checks if I, for example, should interpolate the entire section. So, you know, if this is a section that I want to have the integral for this point, I need all of this, right? So I just take the entire section, this entire section, and then only that subpart. And so, yeah, that's all working now, it seems. This was fun. Next steps will be pain too, though, I guess, because then I need to do new stuff again on like my agenda of way too much stuff. We have this first step now of all these steps that I need to do. And then I need to implement a parser for this JSON and some examples, and I don't know. I get some of that, I think. Great. I hope you got enough, because, you know, the test that will be applied next time it must be 1? What do you do with the test? You don't win it, right? You succeed with it. And if you don't succeed, you get permabanned from Twitch, I heard. Like entirely, can't even watch. Yeah, you should be shaking. I haven't done integrals in over 12 years. Oh, I see. I mean, for me, it's in over 5 years, I think. Nah, I did some of, I'm not sure. At some point I helped someone do some integral stuff, so, but not like as intense as this. And especially not in a numeric way, because this is all numeric approximation, right? Also with like, this is how the integrals are calculated, and I thought I do it with the red things, but that's just wrong, right? You to do it like the green things, and I just needed to get into a lot of stuff. But now it feels like it's working, and I can next do the, oh yeah, this isn't even done. I need to also add this inverse sampling, and then I'll be done. I need to do this with that first section. I learned applied math, so I knew how to use it, but not what it actually meant. Oh, I see. What about probability? You mean in this here, or what you're referring that question to? Because these are like probability density functions, because I normalize them. They are not like, this isn't the probability density function, right? This is just, in a way, you define like difficulty 1, I want to see 5 times. Difficulty 2, I want to see 10 times. And then I, out of that, make a probability density function. Will each square have its own difficulty level? Oh yeah. Basically, I say basically all the time. I basically say basically all the time. It nearly said it again. Each square will not have just a difficulty value, but a difficulty spread. And then from that region, I pick a value. So I'm actually not fully done. When I'm done with all of this, there will be like equally distant. So let's say this is my difficulty, right? Then what I will do is I will have, I don't know, 20 squares here. So what I do is I say, okay, this is one thing, this is one thing, this is one thing. So I split it on the cumulative density function in 20 equal things, somehow like that. And then I pick in between that with this inverse interpolation. And so each square has a range, and the spread will be like depending on how you do the density function. And then the website is here to, because it's so damn complex and unintuitive, I hope that the website will be there that you can like just move this point here, and then you see how your difficulty spread on the board changes, and you can directly understand that, or not, I don't know, but that's like the idea. Yeah, and then afterwards I have like a placement strategy. So maybe you want to have the highest difficulty in the middle and the lowest outside in the beginning. So I would apply like Gauss on the board, and then you have that spread. Or I don't know, you want snake house like, so I go like in this direction and place the squares, and then I do way more weird stuff like synergies. Squares that have the same location can't be together. They are sometimes of groups that exclude themselves. They are like groups that maybe sometimes exclude themselves. Then I place all these exclusion stuff And then hopefully a board comes out of that. Yeah. But in the end, these simple examples will just look like this, where you have random placement. Here you have there's like a version on BingoSync where you have goals in like buckets. So what they do in their algorithm, which is supported by mine because mine is a superset of them all, per per square you can set what goals are possible, and then they were just randomly picked by that square. So you can do all of that too with this. You don't need to use like the full thing or even use this PDF or anything. But yeah, that's actually the wrap up of today. But I will actually, just after sleeping, be back on, and I'll try to sleep not too much. Then I will do Jedi Survivor speedrunning though. I want to try that out. I want to see if I can spend all day tomorrow to get like a speedrun that is around 1 hour. That should be possible if I understand the route and can just execute it. Maybe not. If I stop at some point with that, I will continue with this though. So yeah, I'm quite excited for that. I asked in the speedrunning Discord of Jedi Survivor, oh yeah, Poggies, on how I should do that, and they gave me some tips. So my plan is sleep, wake up, maybe set up some OBS things so I have speedrunning splits. Maybe I don't even do that for the first time, and then I just go and copy their run. And hopefully my PC doesn't crash at any point there. Yeah, so that's the plan for tomorrow. So anyone that wanna drop by for that is welcome. And then again, the wrap up of today is we had the board already the day before. We had this plotted, and then what we did today basically was rewrite the entire class at the normalization, at the not interpolation, at the integral normalization. And so all of this here is rewritten on you. And with that, I think I go to the end screen and then to bed. Yeah. Let's see if we have an continue here somewhere. Yeah, that makes sense. Okay, so we stop here. Next time we continue with the inverse sample points. And I'll find the ending here. Nice. Okay. That was way longer on than I wanted to. Sounds like you're having a lot of fun. Oh yeah, it's great, especially because my current work tasks are monotone and annoying. This is just, you know, it's taking my brain and using it, and it's creative and interesting and a lot of puzzles to solve, so this is just great. And there's no pressure to be done with it anytime soon. So yeah, lots of fun. Okay. Just thinking, I'll listen to that song anyway, so we have like 2 minutes to go. Okay. So yeah, I'll be back tomorrow with all of that. And I hope it just all works out. And if it does not work out for speedrunning, I'll just continue with this. And I hope it will be working. Otherwise, I'll just do like a break and then restart PC or something for this. So that should be fine. Okay, with that, oh yeah, hack commands. Do I not have that? Can't be. Okay, I'll add that in a second. The curse of having too much open. I can't find a tab. 70. I hope you're doing good too, Modern, having like fun with the tasks you could have. You said something about doing some coding for Hitless, Team Hitless or something like that for their website. That also sounds quite interesting. So I just hope that you have like nice things to work on the new website. Oh, great. Been fun so far. Oh, nice. But you don't do that, like that's just free time, right? So not like your main job now. Doing work on an initiative by an ex-coworker. Oh, I see. That sounds also cool. Team Hitler staff volunteer. Oh, I see. So which hackerman do I want? Definitely need this one. Insufficient privileges? Wait. I can't use zero width emotes on 7TV if I'm not a subscriber. Interesting. Also math emote bitte. Oh yeah, true. Math. Oh, I want the zero width emotes. Damn it. Oh, this is also great. I think I rather like this math emote because it's one of the few, it seems like, that is not confused by the math, but you know, actually using it compared to the other ones. This is amazing. Okay. Calculate. That's at least how I feel, like really competent and, you know, everything working out. And then in the end, it's not. I don't have like really coding modes, right? What about some, I don't know. Oh, I use Visual Studio Code, right? So I could have a VS Code emote. I mean, why not? God damn it, I should sleep. Why am I looking into this now? It's just not smart to do. Yeah. Because why not? I'm just stalling a bit, you know. Debugging must be a cool emote somewhere. There are only three emotes on the entirety of 7TV called debugging. Okay, this is the last song. When this one is done, I go sleep. Until then I search for debug emotes. Copium? No, no copium. Surely, you see. Error. That's a great one. Oh no, the song is and it doesn't have too much longer. I need an error code that I like. Yeah, this one is fine. Is there a reason why it's spelled surely and not surely? Can it be that both work? Surely? Surely both work. Okay, that's the last song. Goodbye. Thanks for watching. Have a great rest of your day. I'll be back tomorrow. And I hope it will be great. I need to stop in the song now, which is sad, but that's how it is. When the drop comes. Oh, I see. It's just spelled wrong here. Fine, I fix that. But with that, bye.